Hi, my name is Caitlin Kruger, and I'm going to be discussing FRQ 2010 number 4. Part A asks us to find the area of R. And so our first step is to remember the area formula between two curves, which is the integral from A to B of the top curve minus the bottom curve, dx dy. So in this case, because both of the formulas are in terms of x, then it is much easier to do it to solve in terms of x. We know that the boundaries must also be in terms of x. So we can see that this area is between x equals 0 and x equals 9. So we can apply those to our a and b values. Next, we identify which is our top curve and which is our bottom curve. And in this problem, y equals 2 root x is our bottom curve and y equals 6 is our top curve. So we can subtract 6 minus 2 root x, solving it in terms of x, so we have dx rather than dy at the end. Step is to find the antiderivative of this from 9 to 0. The integral from u to the power of n is equal to u to the power of n plus 1 over n plus 1. And in this problem, we're not allowed to use a calculator, so it's really important not to rely on integration through your calculator and actually know every single one of these rules. So we can technically rewrite 6 as 6 times x to the power of 0. And so using this rule, we see that integrating this will give you 6x. And then we can technically rewrite 2 root x as 2 times x to the 1/2 equal to 2x to the 3/2 over 3/2. So next we use our boundaries, 9 and 0, to subtract our larger boundary minus our smaller boundary. So we plug 9 into this formula here, and then subtract that by the value of 0 plugged into the formula here is equal to 18. And it's very important, even if it doesn't ask for it, to include units. And if you approach this problem and you just have no idea what you're doing, just get as far as you can. At least try to set up the equation even if you can't solve it. Now we can move on to part B, which asks us to write but not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 7. The formula to find the volume of a rotated figure is pi times the integral from a to b of the outside minus the number or the line that it's rotated about squared minus the inside minus the number squared dx or dy. So when you're rotating a volume, if the line you're rotating the volume about is perpendicular to the x-axis, then it's in terms of x. And where it's perpendicular to the y-axis, it will be in terms of y. So in this case, you can see that y equals 7 is perpendicular to the x-axis. When we're solving in terms of x, we have the same boundaries as in the area from 0 to 9. Next, we determine which is our inside and which is our outside curve. So it sometimes helps to draw it out. You can see here that when you are subtracting this inside green portion, which is the volume of this y equals 6, from the entire volume of the y equals 2 root x. So that makes y equals 2 root x our outside function and y equals 6 our inside function. You basically just plug in your different values and you come up with your answer, which is pi times the integral from 0 to 9 of 2 root x minus 7 squared minus 6 minus 7 squared of dx, and you don't need to simplify that. So a hint for problems like this is to make sure you're reading it well when it tells you that you do not need to evaluate the expression, because that will save you tons of time. Part C asks, region R is the base of a solid. For each y, the cross-section of the solid taken perpendicular to the y-axis is a rectangle whose height is 3 times the length of the base in region R. Write but do not evaluate the integral expression that gives the volume of the solid. So it's like having rectangles come out of the page like this from the graph. So a little bit hard to imagine, but the formula for volume is equal to the integral from a to b of the area of the cross-section dx, or dy. Then, first we're going to determine whether it's in terms of x or y, and because it is perpendicular to the y-axis, we know that it is in terms of y. So the integral boundaries are not from 0 to 9, but from 0 to 6. Next, we need to find what the area of the cross sections is equal to. So I drew a picture down here of one of the rectangular cross sections, and we can see that the base of the cross section is equal to 2 root x. But we need to make that in terms of y rather than in terms of x. So we divide y by 2 and then square both sides of the equation, and we get x is equal to y squared over 4. So y squared over 4 is the length of our rectangle, and then it tells us in the problem that the height is 3 times that. So because we know that area is equal to width times height, our area will be y squared over 4 times 3y squared over 4, which is equals to 3 over 16 y to the 4th power. Our final answer is the integral from 0 to 6 of 3 over 16 y to the 4 dy.
Hi, I'm Rebecca, and I'm going to teach you guys how to solve questions number 7 to 9 from MC3. First, we're going to look at number 7. An equation of the line tangent to the graph of y equals 2x plus 3 over 3x minus 2 at the point 1, 5 is. So for number 7, we have to know the quotient rule for derivatives, which is low d high minus high d low over low squared. So I just applied quotient rule to this problem. And then the thing that we have to remember is that derivative of a constant is always 0. So d over dx of 3 and d over dx of 2 is 0. And I just solved for it, and I got y prime equals negative 13 over 3x minus 2 squared. And then using the given point 1, 5, I just plugged it into y prime. And then I got negative 13, which negative 13 is the slope at that point. Since we know the slope and the point, I just plugged it into point slope form and got 13x plus y equals 18. For this problem, we have to know how to find a derivative and don't get derivatives mixed up with antiderivative. And we have to know the quotient rule for derivatives. We also have to know that the derivative of a constant is always 0. So for number 7, the answer was B. For number 8, if y equals tangent x minus cotangent x, then dy over dx is. For number 8, we have to find the derivative of tangent x, and we have to find the derivative of cotangent x. And then after we find it, we have to plug it into this equation, which is dy over dx equals d over dx tangent x minus d over dx of cotangent x. So derivative of tangent x equals secant squared x, and derivative of cotangent x equals negative cosecant squared x. And don't forget this negative sign. And I just plugged it into this one, which is y prime equals secant squared x plus cosecant squared x. So the answer of number 8 is E. For this question, we have to be careful with this sign right here. We have to know that it's negative. For number 9, if h is the function given by h of x equals f of g of x, where f of x equals 3x squared minus 1 and g of x equals absolute value of x, then h of x is. For number 9, we are given 3 important equations, and we have to use this to find h of x. Since h of x is f of g of x, we have to plug in g of x into f of x. So I just plugged it in, so I got h of x equals 3 of g of x squared minus 1. And since g of x equals absolute value of x, I just plugged it in, And for absolute value of x, we don't know if x is negative or positive, but when it's squared, it's always going to be positive. So I got h of x equals 3x squared minus 1. So the answer for number 9 is E. And for this question, we have to just be careful with this step right here. We just have to know that x can be either negative or positive.